All right, so we are at a point where we are ready to start reducing the mercury down to the metal. Now, the reason that I was hesitant about going this way and I didn't decide to just do this for, by default just from the word go, is because borohydride reductions tend to produce fizzage, right? If it fizzes, then it is producing aerosols. And aerosols that contain mercuric ion or little bits of elemental mercury are going to be very dangerous. Aerosols, of course, will, be carried by whatever air currents happen to be around and will settle on whatever surface they happen to come across, thus contaminating every goddamn thing they touch. And droplets of water, in other words, droplets of the solution, can be very, very small indeed. They can be too small for you to see. And so aerosols, right up there with ultrafine dust, are a source of concern, or at least they should be if you have any measure of sanity whatsoever. So we are going to mitigate this by doing this when it is at a cool temperature. It's below the air temperature, so being the middle of fucking August, it's pretty goddamn hot out here. But this stuff is cool to the touch, so it's not super hot or anything. We've got it stirring. We've got it in a tall walled vessel that will hopefully catch most of the droplets. And we're only going to use a little bit of borohydride at a time. Well, here's sodium borohydride. Same old, same old. You guys have seen it a million times on this channel. And we are just going to add it in there. As you see, it starts precipitating out elemental mercury rapidly. Now, the nice thing about this shit is that if you add enough of it, eventually it will completely drop out the metal as a nice isolated solid on the bottom of the beaker. And hopefully it will not go back into solution, which is one reason we wanted to raise the pH a little bit. One of the reasons. See what I mean about aerosols? Little droplets of it on the side of the beaker already. Hanging out in that fucking cloud. Let it stir for a little bit with our mercury sludge. Man, this is so bad. See, this is why my bench is made of wood, so I can burn it if I have to after I do shit like this. And I'd love to be able to stir it more vigorously than this, but if I try to, the stir bar will get thrown off to the side, and then I'll have the fun of having this shit still quietly fizzing while I've got to sit there and fuck with it and try to get the stir bar in place. And here we go, right on cue. I hate this stir plate. I hate it. When it finally dies and its usefulness is done, I am going to invent new ways of destroying it. I am going to come up with something truly epic for this motherfucker. I don't know what, but it's going to be something to behold. Maybe it's just getting full of sediment. Oh, yes. Okay, here's a good sign. Notice how, well, I might have been able to. Let me get it stirred up here. You stop the stirring and you give it a minute, you'll start to notice that shit is settling out. See that? It starts to separate out quickly. Yes! Yes! Okay, now we're getting somewhere. Ha ha ha! That's right. Oh, would you look at that? I don't know. Can you see anything? Probably. It always doesn't look like you guys can see shit. And then I go back and I edit the video and it looks great. Okay, so yeah, we got our Mercury here. It's all just raining down out of solution. There is quite a fucking bit of it in there. Holy crap. Wow. Okay, so I precipitated out a lot of this gray shit. And then I filtered it off just through a coffee filter and transferred it to this beaker here and heated it up with a cover on the beaker and stirred it. And we've got this dense metallic stuff. I'm honestly not sure exactly what the deal is. It is definitely not a liquid. I am not sure what's going on there. This is the filtrate. What I'm going to do with this is just add alkali to this bitch and drop out the mercury that remains within the filtrate as mercuric oxide, like so. That's very simple and straightforward. There really ain't a whole lot to see. We just add in alkali and precipitate it out like that. Now I've got to filter this mess. Yay. So, I mean, that actually looks really clean. Nevertheless, I am curious about this. So, although we've been able to drop out any mercury that's left in solution here as the oxide, I want to continue to experiment with this a little bit and see what I can do. Now, this is mercury that I have had sitting in a flask for the last, 4 fucking years. I can't even remember exactly where I got it from. It was dirty mercury that somebody sent to me, and I just have never gotten around to doing anything with it. I want to add it to this and see what it does. I'm just wondering, if we add some mercury to this, will that stuff start to absorb into it? Exactly what happens here? What does happen here? Interesting. Well, the clumps of mercury disappear and it looks like we have more of this powder. Alright. Holy shit, it really did. That shit is gone, man. Okay. It's like it all just came together and merged to form more of this powdered shit. That is very odd indeed. Well, alright. Still leaves me with the question of what to do with it, but I feel a little better calling it mercury, I guess. I think what I'll do is I'll make some nitric acid and I will filter this shit off. And then I'll dissolve it in the nitric acid. That'll give me mercuric nitrate. And give me something to do with this here too after I filter it off. That's probably what I'll end up doing with it. But let me filter off this mercuric oxide here, and we'll have that, and we'll have this, and then we'll pick this up again in the morning. Okay, so here's the deal. Right now, I am filtering off the mercuric oxide so that I can rinse it, flush out as many impurities as possible, and then we will redissolve that bitch in nitric acid. Separately, we will take the precipitated mercury, which we have down here. See, it's very nice. It's just a gray powder. And we will dissolve that in nitric acid. Then we will take these two solutions of mercuric nitrate and we will precipitate out mercuric oxide again from both of them. And that, I think, because I've been very careful not to add other metals to my recycling here, I think that's going to give us a fairly pure product. Since I'm already working with it, and since I'm going to, I might as well turn it into something that's actually useful. Mercuric oxide is useful. That's a useful compound to have in your collection. But mercuric chloride is really the most useful form of this. And since people keep bugging me, like, do a video on amalgam reductions, people want to see variations of the Clemenson reduction as it applies to nitroalkenes. I can't imagine why you would want to know that. Probably not making anything good. It's probably some goddamn phenpurpylamine instead of some nice phenethylamine. But hey, whatever, who am I to judge? If the public says you want to see such a reduction, then we will do such a reduction. I'll be with nothing that's going to give us something that will land us in prison. Anywho, probably going to have to be with the beta nitrostyrene, because I don't really have anything else, any other kind of nitroalkene that we can use, and I don't have enough benzaldehyde to make another one. I don't know. I guess you could use a substituted benzaldehyde. I wonder how that stuff that you use to drop out like metals works. That's a thought. Put that on the back burner. Anyhow, back to the task at hand here. So yes, I think that if we do that, we will end up with a pure product. Then we will just convert the mercuric oxide back to mercuric chloride. We will allow that to crystallize out because it makes nice, big, pretty crystals. And because if it's crystallized, it should be pretty goddamn pure at that point. We will, of course, recrystallize it, all while trying not to generate copious amounts of waste, which kind of defeats the whole fucking point of doing this. It's inevitable that we will generate a little bit of mercury waste, but it should be like of a volume that is significantly smaller than what we started out with. Otherwise, what's the goddamn point, right? Now, a couple people have asked me about wastewater. Well, the wastewater is pretty easy. You just discard it. The wastewater for this is very alkaline. Mercury and something that has a pH this high, which it's like somewhere between 12 and 14, is going to be most stable as the oxide, so it will precipitate out. Now, yes, you can see there is a little bit of it suspended in the liquid there. However, the trick to deal with that is to let it sit overnight in the covered beaker, allow everything to settle out, decant off the clear liquid, and then refilter the shit that's at the bottom. Filtering this stuff is a goddamn nightmare. That is right up there with barium sulfate in being a complete pain in the fucking ass. I started filtering this bitch yesterday. Okay, and you see, filter paper is like, got shit, and I had to let that shit sit overnight so that the filter paper would be impregnated with this shit, and then filter it today. And then I added a little bit too much beyond the filter paper that had been treated yesterday, and it came through. Anyway, so now I got to do this shit again, man. I swear to God, filtering this is a bitch. Which is funny because, like, as you can see, it settles out a solution or a suspension nicely. It's heavy as fuck. I swear, this element is an asshole. It goes out of its way to be difficult. I don't know why. It just does. Anyway, I'll come back when we are ready to dissolve this shit in nitric acid, which I still have to make. Okay, so this stuff has been sitting around for several days. I spent yesterday making up some more nitric acid. It says crude because I just distilled it once. I haven't fractionally distilled it or processed it in any way. I don't know that we'll need to. Of course, it's kind of a golden yellow because there's nitrogen dioxide dissolved in it. So, yeah, normally I would redistill it to get nice, clean, azeotropic white nitric acid, but Again, I don't really think that we need it here. This is all of our mercury that we recovered as the oxide. This is all the stuff that was precipitated out, plus that dirty mercury that I added to it. This had been sitting for several days, and it had all kind of consolidated into one big blob. But for some reason, it appears to have broken up and is much more difficult to see now. But there are little blobs of the metal under there. I'm wondering if, if it sat for a very long period of time, how much of it would eventually consolidate down into a nice liquid blob. I'm beginning to have serious concerns, though, about this powdery shit, because if it really is precipitated mercury, I would imagine that it would start to consolidate into a liquid. But I hadn't seen any more liquid in here than what I poured in here to begin with. It doesn't seem like, it's happening to more of it. So I'm beginning to wonder, exactly what the hell it is. I'm sure it's got mercury in it in some way, shape, or form, though. It's okay, because in both cases, what the plan is now is simply to dissolve these in nitric acid and convert the mercury in both of them into solutions of mercuric nitrate. We will then reprecipitate out the oxide again. This should separate out anything else that's remaining. After that, we'll take that oxide, we will then convert that into mercuric chloride. That should crystallize out in nice, big, beautiful, pretty crystals. And we can always recrystallize that product if we have any concerns about its purity, and just recrystallize it from boiling water. And that should be fine. So, I mean, really, at this point, I hope you can see that recycling mercury really isn't all that difficult. I still haven't quite worked out how you can exactly get all the aluminum out if you've been using aluminum amalgam without having to resort to distilling the shit. You may have to. You just might have to accept that for you, you're just going to have to distill that mercury and recover it that way. That is a possibility. Anyhow, we will proceed with our plan with this stuff and make some mercuric nitrate. Alright, so I completed the extremely messy business of getting that coffee filter out of there and rinsing almost all of the mercuric oxide off of it. There was a little bit I wasn't able to get off, which I just finally decided had to go in the trash. It'll go into the landfill where it will be prevented from being released into the environment. So don't panic, we're not contaminating the world here. Now in this, I added about, maybe about 25 to 30 mils of that nitric acid. Probably closer to like 20, 25. But as you can see, the mercuric oxide dissolves readily in strong heated nitric acid. I've got the heat on. This is still not too hot to touch. It's gonna get uncomfortable soon. So as you can see, it does it fairly readily. If we just let this keep going and stirring, we might have to add a little more acid. We want the solution to be hot but not boiling. It should eventually completely clarify. We'll let it do this for a little bit, and then we will filter this through a plug of glass wool that's been compacted pretty damn tight. It'll take a long time, and it'll be tedious, but happily, mercuric nitrate is nice and soluble. Glass doesn't react with acid, and it should capture any teeny tiny particles that are left over, we hope. So, I'm going to let that happen. I will check back in later on, and we will try to dissolve the other stuff that we've got. Hopefully that will be kind of easy, because this has taken all of 5 minutes. Okay, addition of about 3 or 4 more mils of the nitric acid. And letting this stir for about another 2 or 3 minutes has given us a completely clarified solution where all of the mercuric oxide and I think it produced the mercurous nitrate as a white precipitate when I first started adding in the nitric acid. This is not unexpected. But all that shit has gone into solution, and now everything is in there as mercuric nitrate. So, very nice. And yes, if you add concentrated acids to an excess of mercuric oxide, they do not go into, basically you get a reaction where you end up getting a fair amount of a mercurous salt, which is not very soluble, and you'll see it as white precipitate. It happens with hydrochloric acid, you'll get mercuric chloride, and with nitric acid, you'll get with hydrochloric acid, you'll get mercurous chloride, and with nitric acid, you'll get mercurous nitrate. But with hydrochloric acid, no matter how much acid you add, that shit ain't going away, man. That shit is there to stay until you like bubble chlorine through it. But with nitric acid, since it's an oxidizing acid, it doesn't take very much for it to begin to oxidize all the mercurous nitrate to mercuric nitrate, and the problem goes away. So, yay. Yes, this is why you can't just dissolve mercuric oxide in hydrochloric acid to get mercuric chloride. It doesn't work. You end up with mercurous chloride. That's why you got to heat it up and stir it and bubble chlorine gas through it, which generates trichloride ion, which oxidizes everything to mercuric chloride. That's why we do things that way. Anywho, this is done. Time to try the other stuff. Oh, I've been treading this. Alright, this stuff has been stirring and heating now for a little while. Hopefully, this should react kind of quickly. Here goes nothing, people. Ooh. I have serious concerns that the high volume of liquid in here is going to dilute this shit down to the point where it's just not going to reach a high enough concentration. There. Now, we're going to let that heat and stir and see what happens to it. Something seems to be happening. Alright, if piece of shit has decided that it wants to stay in focus this time, there we go, you can see. So, adding the bromine and just very gently heating this, it's like barely warm to the touch, was all it took to completely clarify the solution. Because halogens are so freaking useful, man, I swear. I don't know how people do chemistry without having, like, chlorine and bromine readily available, because they're just so goddamn useful and so handy to have around. Anywho, So as it's warmed up some of the bromine has gone into solution, which is why it's turned this nice amber color. And the solution is completely clarified as predicted. All of the mercurous salt has been oxidized to mercuric salt, so that's what it is. And I made another video a long time ago thinking that this was a viable way to make mercuric bromochloride. But I think what it really ends up being in the end is either going to be mercuric bromide or more likely just mercuric chloride. I don't know that... Well, I don't know. I don't know what happens to the bromine. Anywho, it doesn't really matter. In the end, all we care about is that it all got oxidized and it's all in solution. The little bit of crust that's on the side here, the vapor, will start to get that. You just adjust now, put the cap back on this thing. So we'll let it warm up here and just keep going. I wonder if bromide reacts with, or bromine reacts with chloride to form like a trihalide, a mixed trihalide ion. Is such a thing possible? Is it stable enough to exist even as a fleeting intermediate? Because I would think that that would be a very powerful oxidizer indeed, given that it's asymmetric. Anyhow, I will come back when there's some other change to show you guys.